Coming up in this video, we're testing a device sold as a metal detector that reacts to water, plants, and even bananas. We're going to tear it down, look at the circuit, and show you exactly why you might be getting scammed. You won't believe what's actually inside this thing. Metal detectors are incredibly important tools. From airport security and industrial applications to archaeology and finding lost treasures, they save time, money, and in many cases, even lives. But a problem arises when something that isn't a metal detector is sold as if it were. Nowadays, especially online, there are various devices being marketed as metal detectors, but they don't actually detect metal. This isn't just deceptive advertising. It can lead to financial loss, frustration, and even safety risks depending on how it's used. And that is exactly what we are going to show you right now. This right here is one of those devices. It's advertised as a metal detector, but what it actually detects might surprise you. Let's run some simple tests. First, water. Curious, right? Water isn't metal. Unless you're in the desert searching for a well, detecting water isn't very helpful for someone who needs a metal detector. Next, plastic. Plastic isn't metal either. Still, it triggers. What if we use a banana? Definitely not metal. Unless you're lost in the jungle looking for a snack, this isn't doing much for us. Let's try it on a plant. No metal here either. And finally, on our own bodies. Our bodies aren't made of metal. But on the bright side, maybe we can use this to check if there's someone hiding in the closet. And yes, it does react to metal too. But do you see the problem? It reacts to practically anything. So the question is this actually a metal detector? Or is it something else entirely? Let's open this device up and see what's inside. No complex coils, no typical metal detector circuitry. If you have a background in electronics or have worked with sensors, take a good look at this. In your opinion, what kind of device is this? Let us know in the comments what you think this really is. We already know what this device is, but let's try to sketch out a simple diagram of how this circuit works. Nothing too technical, just to get the idea across. Now, let's look at a more refined version on the computer. We have an NE555 timer and a PIC16 microcontroller. On the actual board, the chip markings have been scraped off, but everything indicates it is indeed a 16 microcontroller. Here, we can better understand the operating principle. This is not a traditional metal detector. This is a capacitive sensor. It reacts to changes in capacitance. In other words, it detects the presence of water, the human body, plants, and nearby objects. That's why it detects everything except metal specifically. When we press the power button, the circuit is powered by a 9 volts battery. This goes through a converter that steps it down to 5 volts to power the components. The NE555 circuit is acting as an oscillator, and the frequency is defined by a virtual capacitor, which is this printed circuit board right here. The inner area is one plate of the capacitor, connected directly to pins 2 and 6 of the NE555. The outer area is the other plate left open. When the device is turned on, the 16 microcontroller analyzes the signal generated by the NE555 and saves that baseline value to its memory. When we bring this sensor plate close to an object, the capacitance increases, which causes the frequency of the NE555 to drop. When the frequency falls, the 16 microcontroller detects the change and triggers the alarm, sounding the buzzer and lighting up the LED lights. So, as we mentioned before, this is a capacitive detector, not a standard metal detector. Consider this a warning. Not everything sold as a metal detector actually is one. But we aren't stopping there. In our next video, we're going to attempt to transform this capacitive sensor into a real, functioning metal detector. We'll see if we can salvage the shell and the basic components to build something that actually does the job. If this video helped you out, give us a like, share it, and comment below with your thoughts on these kinds of devices. And if you want more videos of us disassembling, testing, and explaining electronics in simple terms, make sure to subscribe to the channel.